Welcome to today's webcast, brought to you by DataVale. I'm Stephen Faig, Director at Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, Upgrading SQL Server to 2012 and Beyond. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. And we will have a few polling questions today throughout the presentation. Please take a moment to select your answer when they come up. The results will be shared live. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if you've won. Now, to introduce our speaker for today, Andy McDermott, SQL Server DBA at DataVale. You can check out Andy's bio by clicking on the arrow under his photo. Now I'm going to pass the event over to Andy.
Hello everyone, my name is Andy, and thanks for joining our webinar on upgrading SQL Server to 2012 and beyond. I'm a DBA here at DataVale. If you don't know who we are, we have a lightweight monitoring utility that helps us keep tabs on database servers, and I work with a great team of DBAs that can respond to any issue, day or night. When we're not doing that, we're helping our clients with project work or just working to keep things running smooth. But enough about me, let's talk about you. If, or you, I'd like to think, are also a DBA or some kind of IT director. You know there's a few recent SQL Server versions out there, 2012, 2014 right now, and 2016 is coming down the pike. If you're looking at your SQL Server environment right now, in most cases the SQL versions are still 2000, 2005, or 2008. You're ready for 2012 and beyond. But looking into that process to upgrade one or many of the servers, you can see there's quite a bit to think about, lots of things to consider, and maybe different approaches to minimizing downtime or how to use some of the newest features in SQL. Lots of challenges like how to provision a new database server or understand Microsoft's new licensing for SQL Server. So that's exactly what we're going to talk about today. I organized everything into these question topics, and this is how we're going to hopefully step through everything. Who? Well, we already talked about you and me. The real who here is the SQL Server we want to upgrade. What? What kind of upgrade can we do here? As you'll see, there's some limitations that might dictate the upgrade type. Where? Here we'll review some potential targets and destinations, where the new SQL Server will live. We have live options here, so we'll get into that. Why? One quick answer to the question why is because the older SQL versions are falling out of support. Support has ended for 2005, and 2008 is already into extended support. That's the easy answer, but we'll actually go deeper and look at a few of the new features that would help make an upgrade worth the effort. And how, lastly, we'll get into a few methods to minimize downtime and how tools and techniques for actual performing the upgrade to keep it smooth and successful. We have a lot to go over, so we'll get started, but first we have a poll from Stephen.
Thank you, Andy. We're ready for our first polling question today, and the question is, what is your main challenge in upgrading? Licensing costs, resource provisioning, project planning, staff, or a combination of the above? And while you select your answer, I just want to make sure you stay tuned until the end of this presentation today. We are going to direct you to a page where you will have a chance to win a free SQL Server upgrade assessment from the experts at DataVale. Okay, and it looks like the results are in. So 10% of you chose licensing costs, 3% of you chose resource provisioning, 20% of you chose project planning, 13% chose staff, and a whopping 51% chose a combination of the above. Back to you, Andy.
Thanks very much. All right, so we're moving into the what topic. When I say what type of upgrade, I mean this. It's either an in-place upgrade or a side-by-side upgrade. Just like their name describes, an in-place upgrade means everything at the hardware and operating system level stays the same. The DBA double-clicks the SQL install executable, and the installer works away and upgrades the existing old SQL instance to a new version. On the other hand, a side-by-side upgrade means the DBA sets up a whole new system with the target SQL version and then works to migrate the database and anything else that's important from the old server to the new server. You can probably already see some of the advantages and disadvantages of each method. And an in-place option is very committing since it can be pretty difficult to roll back an in-place upgrade. But it's very easy and fast. Just fire up the installer and click through next, 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 next. So in actuality, it's a little bit more to it, but you get the idea. The side-by-side upgrade is potentially much easier to roll back, and you can really plan ahead by setting up the new server ahead of time and let it burn in, run load tests, etc. But of course, the whole thing is more complicated and more expensive to set up. There's two systems, the before and the after, and they'll be running concurrently for some time. So you'll need that extra server, some more disk space for the backups if you're maybe copying backups over. You really need a good plan, some kind of migration plan to move the data over and so on. So why or how to pick one over the other? In my thinking, there's one critical topic that will dictate which will be the best choice, and that's licensing. So as you might have heard, Microsoft changed the way they do licensing since 2008. As far as upgrading, it kind of draws a line in the sand between 2008 and 2012. So let's review SQL licensing and get a better feel for this. So here we have a list of license options. In SQL 2012 and above, we just have the two. Server plus CAL. CAL is a client access license. In this case, you buy a server license plus usually a pack of CALs. Anyone or any device with a CAL is licensed to connect to that server. Core licensing, on the other hand, means you pay the license server and you get unlimited connections to the SQL server, but the cost of the license is per CPU. The more power your machine has, the more expensive the license. Software assurance, this is not a license option, but it kind of goes along with these two. Software assurance, many of you probably already know, is sort of a longer-term agreement with Microsoft. You commit to sticking with Microsoft technologies, you get certain benefits and advantages. You don't have to have it, but especially since SQL 2012, some of these benefits really make a difference to the way you might set up a SQL environment. Okay, just to round things out, let's see how we can license a new server, just so we get a feel for it. So for standard edition, you can either license two options. You can use the CAL or the per core option. For that, you get 128 gig of RAM, and the lesser of 4 processors or 16 cores. For enterprise edition, we get basically unlimited RAM and CPU, up to, of course, the server limit. We can only use the per core option. We'll not be getting into any BI stuff here, but just so you know, there's also this BI edition, which only has the CAL license. So all this is good to know, but how does it relate to our upgrade? Well, let's look at how licensing worked before and after SQL 2012. If you look at a motherboard of a computer, you'll see something like this. Not exactly like this, but you get the idea. Just like this electrical outlet here, motherboard adds one or more sockets. Into each socket, you plug a processing chip, and you're ready to compute. So SQL Server 2008 and earlier, licensing was based on this socket count. The license cost was per socket. But of course, each processor chip we plug into the socket is actually worth several CPUs, since typically these are multi-core processors. But that didn't matter too much to SQL 2008. It only licensed for the socket count, regardless of the core count. Then in SQL 2012, Microsoft decided to license per core. So for our example here, we've gone from counting the 2 sockets to now counting 4 cores. But just for the record, you have to buy at least 4 cores. And after that, you buy them in packs of 2, which makes sense, right? Otherwise, you might end up with something like 9 CPUs, and that would be kind of odd. So from 2 sockets to 4 cores, it might be no big deal. Take a look at this case study. Here we have SQL 2008 server, 1 socket, 4 cores, so 4 CPUs. If we ballpark, Microsoft charges $28K per socket, and that's our license cost. However, once we upgrade to SQL 2014, we use the per core license. Microsoft says that the license per core is about 1/4 of the old socket price. So in this case, we have 4 cores for about $7K, and the math works out fine here. You'd pay about the same for each one. But if we take a look at this slide where we have a similar situation, except now we have 2 sockets and 6 cores per socket, or sorry, 3 cores per socket, 6 cores altogether. So for SQL 2008, we'll pay for the 2 sockets, and that's $46K. But when we upgrade that server to 2014, now we pay per core, and the price really jumps up. Okay. So these are just made-up examples, but you can see the problem, I hope, especially for a high core count processors. You're really going to pay for it in licensing. So just for completeness, let's touch on a few more license topics while we're here. If you have software assurance, you can set up high availability or disaster recovery kind of architecture and still minimize licensing costs. So if you have some kind of secondary server, an always-on replica, or a mirror partner, you don't have to license that as long as you're not doing any work on it. So no DB snapshots or no replica backups. It has to be completely passive. And now you start to get some kind of idea of what the software assurance can give you. If you don't have software insurance, you would have to license each one of these passive instances. It works a little bit the same for virtual machines. If you want to vMotion a virtual machine with SQL installed, you'll want that software assurance agreement. What else here on the VM slide? You can license each virtual machine individually with SQL Standard Edition. And that's kind of where the 4-core minimum might come in as far as licensing goes. There's no point in running a 1 or 2 CPU SQL Server in this virtual environment. Since your license is for 4 minimum, you might as well use all 4 of them. The other option, you can license the entire host as Enterprise Edition and run as many of the VMs as you like. And lastly, Azure licensing is pretty straightforward. You can use one of your existing licenses and apply it towards a SQL installed on an Azure virtual machine, or pick an image from the gallery and pay per minute of use, and that license cost is bundled up in that per minute charge. So to summarize, licensing has changed, and it might be way more expensive depending on your setup. If you're looking at upgrading any SQL server on 2008 or earlier, this is really something to take into consideration. And like I was explaining earlier, as for the type of upgrade, there are a number of reasons to do a side-by-side upgrade, but depending on what you're running now, this licensing aspect might really be the clincher that makes you want to do a side-by-side upgrade. All right, let's move on to where. Where are we going to put this upgrade? So we just took a look at how we might license a SQL Server. We plan to host it on a physical server, or maybe a virtual machine, or even Azure maybe. We have a pretty good idea our upgrade type, which may well be side-by-side. So along those same lines, physical, virtual, or cloud, let's look at some destinations, places where we might upgrade and migrate the server to. First of all, let's take a look at what we can't do. Let's take a look at what we can't do. We already decided we'll be using side-by-side, so some of these might not matter, but in case we could get away with an in-place time and upgrade, these would be the showstoppers. You can't upgrade directly from SQL 2000 to 2012. You'd have to bring it up to at least 2005 Service Pack 4. You can't run SQL 2012 on Windows Server 2003. You could run it on Windows 2008 R2, but you probably would want to consider going all the way up to modern operating system. You can't go from 32-bit to 64-bit or vice versa. Remember, this is an in-place upgrade, so that just kind of makes sense. And you can't go down edition from SQL Enterprise to Standard Edition. You can't go backwards. So enough of the can'ts. Let's look at what we can do. Here we have a lot of opportunities if we go side by side. If we set up a companion server with SQL 2012 or 2014, and then get ready to move the databases over to the new server, that opens up all kinds of options. The new server could be pretty much whatever we want. It could be all new hardware. It could be a cluster if we want to bake in high availability. It could be addition up or enterprise, or addition down to standard to save some money. And you could even change the addition of the operating system. Modern processors are much faster than they used to be, and we have SSDs now. So assuming the legacy server is older and slower disk and CPU, and the new server is comparatively a hot rod, there's an option here to consolidate a bunch of the databases in your environment from these older servers onto a single box that can handle a big workload. Or along the same lines, if you have some kind of SQL Server sprawl going on in your shop, you might virtualize all those low-caliber servers, run them all from virtual. They're not already virtual, of course. The point is here that it's a good chance, due to the licensing changes and other factors, that your upgrade is going to be side by side. You have to do it that way anyway. It might be a good time to really take a look at where you want to be with your SQL Server or the whole SQL environment and work to make those changes, clean house, get lined up for SQL 2016 or more cloud or whatever else is coming next. So a lot to think about, lots of decisions to make. How can we approach this to make a good decision on what might be a good option for our target SQL Server? Well, to know where you're going, it's good to know where you are. So let's try this provisioning. Let's take a close look at what's soon to be the legacy server. We'll just look at the big three resources: CPU, memory, and disk, and take a few ballpark calculations to get a feel for this server's resources. We'll call CPU the speed, CPU speed times the core count times 1,000, just to adjust it to a number that works with the other metrics here. Memory is pretty easy. We can just look that up in Windows Server Properties. For disk, we kind of need the IOPS. You can get that maybe from the SAN vendor, or maybe look up your disk's speed on the internet. So if we have a kind of a ballpark idea now of what our current server is theoretically capable of, we have this kind of resource space that a workload could fill, but we need to find out how much of that is actually in use next. So that can come fairly easy, at least for this high-level look. We can get IOPS, CPU usage, and memory usage all from these perf mount counters here. So let's take a look at how that might look in real life. Here's kind of a case study of a really high-caliber server. We can see it's getting pretty good resource utilization by this percent usage triangle here. So this doesn't look like a good candidate for a VM example. Looks like a new physical service probably in order for your destination. Here's another real-life fake example. Case 2, we have a smaller line of business kind of server. Resource space is also pretty well used, but since it's such a smaller footprint, it's maybe a better candidate for virtualization. So, of course, this is just kind of a high-level sketch. We borrowed it from sort of a consolidation project we're doing, but I'm not trying to say provisioning is as easy or simple. There's a lot of other stuff to look at, but this is kind of a high-level view and maybe a foothold into the beginning of what the process would be like. So as you can imagine, provisioning a new server is a lot easier since we're looking at these metrics right now, and we have something to base it off of. It's much more difficult if you're trying to just do it from scratch. But since it is easy in this case, and we have these 3 metrics or possibly more, one really easy way to go would be to try to migrate this thing into the cloud. And Azure makes it super easy. If you want to, if this is an option for you, you could just know these 3 metrics: IOPS, RAM, and CPU usage, and you have all these options to choose from in your Azure menu. You can just go in, pick your server, spin it up, and migrate your databases over. What's really cool is if you under provision, no problem. You can just level up. Same for scaling up if your load changes and you need to add more resources. And on the other hand, if you over provision, got too much power, you can shrink kind of your resources back down to something where your workload fits inside it better. So with that being said, we'll move on to why, but first, I think we have another poll.
Thank you, Andy. Now for our second polling question today. How would you rate your knowledge of what you need to do before upgrading? I'm an expert, I'm pretty well versed, or I'm a novice and am looking for all the information I can. Please take a moment to select your answer. Okay, and looks like the results are in. So 11% of you are experts, 51% of people are pretty well versed, and 37% I'm a novice and am looking for all the information I can. Back to you, Andy.
Thank you, Stephen. All right, moving on to why. Well, we already talked a little bit about why, partly because support for older versions is expiring, but also maybe you don't want to be a decade or more behind current technology. So let's take a look at a few cool features the latest SQL version has to offer. Plenty out there to read up on this stuff, so I tried to choose a few things that maybe are well less known, a few things that might actually matter to a DBA, especially. So that brings us to the star. The star is the standard edition star, so any of the features we're about to look at, you see the star, it's available in standard edition. There's only 3 of them, so don't blink, you might miss them, but they are there. And one other thing, all this stuff we're about to talk about is all SQL 2014. We've been jumping back and forth a little bit, but this is the newer stuff I wanted to point out. So let's begin with probably one of the most fundamental focuses of a DBA, it's backups. All right, so assuming we take regular backups and we test them and we have all that backup best practice stuff all dialed in, what kind of security should we have around these backup files? Can't always send them direct to tape or ship them off to data storage lockers. We might need to actually use them fairly quickly or right after we take them. So we kind of need them to be around, but we still should have them secure, right? So if you look back on SQL 2005, we could password protect them. That's not really good, and you can see that in BOL there. Suggest don't use this anymore. Then in 2008, we have this transparent data encryption or TDE option. This encrypts the data and log files as well as the backup. It's a great solution. The backups can't be read in plain text, and they can't be restored or attached, at least not unless you have the database encryption key. That looks pretty good, but the showstopper here for many people is that TDE was Enterprise Edition feature only. Now, as of SQL 2014, we have backup encryption, and it's a standard edition feature. It's excellent for anyone running on standard that's currently using any kind of third-party tool to encrypt their backups. It works very similar to TDE. You create a master key, create a server certificate, and then add the encryption keyword and clause to the with clause of your backup statement. One drawback here is you can still detach and attach a database, so you need to make sure you have a good security around your server to limit who can detach and attach databases to cover up that gap. The really good news here is that when you're using backup compression together with this encryption, it's going to actually work as opposed to with TDE backups that didn't really compress at all because the compression was trying to compress an already encrypted string. All right, moving on to cardinality estimation. It's a pretty interesting new feature, or a rework of something that's been in the engine forever. Cardinality estimator is part of the query engine that interfaces with statistics, basically figures out how many rows are going to come back from a given table. That's super important because it helps determine just what the query plan will look like. Will the table get a seek operation or a scan operation? Will a join be a merge join or an inner join? All these kind of choices help SQL get the data as fast as possible. So a couple ways that they changed the cardinality estimator, a couple things they looked at are like the ascending data key and these related column problems. And as you can hear from me stumbling around, I actually tried to take a shot at explaining some of this, but it gets pretty thorny pretty quick. If you're interested, go out and find Joe Sachs' white paper, Optimizing Your Query Plans with SQL Server 2014 Cardinality Estimator, and read that, and he's going to be able to explain it much better than I ever could. As far as upgrades go, this is a pretty important topic since the whole new Cardinality Estimator is turned on or turned off via a database compatibility level. So if you're upgrading a database from SQL 2008 to SQL 2014, especially since we're focusing on side-by-side upgrades, you need to ensure to set the database compatibility to match the instance version. So for SQL 2014, that's 120. If you want the cardinality estimator to be turned on, Microsoft is pretty confident it will be a good thing and it will result in much better query plans. But just in case it makes things worse or you find your performance takes a dive, they give you the option to also turn it off. So to keep your 2014 database compatibility, but use the legacy cardinality estimator, you want to set the trace flag 9481 You can set this up as a startup parameter, or you can set individual queries to use this flag as a query option. On the other hand, if for some reason you want to keep your database at the 2012 compatibility level, which is 110, but you want to try the new cardinality estimation server-wide or just for a particular query, you can use trace flag 2312. So there you have it. Very intriguing feature, and more importantly to us as we're doing this upgrade, definitely something we want to be aware of as we think about the changing database compatibility to match the new SQL instance. Late durability is also a very interesting new feature available in standard edition. Normally, before a transaction can commit, a log record has to be hardened to file, and this is what's called write-ahead logging. The data in that transaction just changed is sitting there in memory in the buffer pool, so if there's some problem like a crash where the change would be lost, that's where the transaction log could get it back. That's why we have a transaction log, and we can say that a transaction log is committed because even though it hasn't been written to disk, we can recreate that change with the log record. So that's the durability in relational databases ACID, D. So delayed durability now, rather than that write-ahead log, SQL just buffers those log records in memory and periodically writes them as a batch to the log file. So as you can imagine, there's a risk here. If we had a crash, we'd lose the changes to the data and the log record that describes it. So that's kind of the risk, but if we're okay with losing that data, we don't need it to be guaranteed, then you can get a good performance increase because we're not having to write every single transaction to a file. We don't have this sort of queue lining up, this bottleneck of writing logs to files. That's a good way to set it up. They set it up so you can kind of do it granularly, either enable it on the database level, and then add delayed durability option to the commit statement, or you can force the whole database to be allowed or disabled as far as the ability to use this delayed durability. All right, let's move on to some of the index changes in 2014. If you have a huge table and a few indexes on that table, and inserts and deletes and updates are all going on, eventually the indexes on this table are going to get fragmented and your performance may decrease. And as a DBA, you need to rebuild those indexes, but depending on just how big those things are, it might not be so easy. How long will it take? Will the operation fit in the maintenance window? How much impact on other operations? Will it be blocking? How will it affect the transaction log, etc.? So in 2005, SQL introduced online index rebuild along with the row versioning function. So that's a good time to reduce, that was a good step to start reducing blocking for index maintenance. Then in SQL 2008, we got table partitioning, and that's kind of where we're going to start with our look at this feature. So this is not the usual way to present it, but let's look at the benefits of table partitioning, strictly from a DB maintenance perspective. So here we have a huge table, it's a big clustered index, and if we had some way to split up the data here by date, of course, is a good example, we can partition this thing into much more manageable units. Each partition can get its own disk. It doesn't have to be that way, but that works well. All right, so now we have this partition table. Each partition is getting updates, deletes, inserts, just like any table, and of course that's causing index fragmentation, but it's just on the partition level. The whole index is still going to report the fragmentation, but you can also examine any of the fragments of a given partition. You can examine fragmentation of any of the partitions individually. So up till now, with SQL 2008, we could rebuild either the entire index as an online operation. So that might help some problems, like maybe the blocking, but still it could be a long, intense process and it consume a lot of resources. The other option was to rebuild individual partitions, but only as an offline operation. So that would take care of T-log bloat and high resource use consumption, but now we're back to having a blocking potential. So as of 2014, we can do online index rebuilds by partition, solve the blocking problem, as well as some of these high resource use problems. So when you're doing an upgrade, that definitely could be something to look at, is digging back into your re-indexing scripts and maybe rewriting them to add this with online statement and by partition. So that would seem to be enough, but wait, there's more. They call it online indexing operations, but it's not necessarily, because even these can block. So if we walk through this scenario here, we can see how that can work. Number one, a process is running against table A, holding some locks. These are shared schema locks, but that's not critical to know. Next, the index rebuild comes along and also needs a lock on that table or that index as well, so it's got to wait. It's not going to be able to also jump on there. So at that point, it's not even an online operation yet. It's not doing anything. It's just waiting for that other process to finish, just waiting in a queue. Process 2 comes along and also wants to use that table. Guess what? It's got to get in line behind the indexing process, and only after the index rebuild has had its turn to jump on the table will it be able to run. So now, with low priority waits, which is the feature we're talking about here, that step 3 there changes everything. Process 2 steps right around the index process because it's marked as a low priority wait. In either case, once the index process begins its work, now it's an online process, and all the good row versioning that make online indexing works comes into play. But until then, it's just wait. So that's what you can control here, is how long it's waiting in that low priority setting and letting other processes bypass it. And what will it do after its wait time is up? It can either start waiting on a normal priority and perhaps block. It can kill the blocking process, or it can kill itself. Of course, while it's waiting, if that table A frees up and no one's using it, the index rebuild process can go ahead and begin, again, as an online operation, non-blocking. So this is an online sort of a feature, therefore Enterprise Edition only. Could be put to good use in our partitioning example we just discussed, but it doesn't have to be. It could be just used on a non-partition table as well. So again, these are some kind of key features that might be worth taking a look at, going back into your index maintenance script and see if you can fix anything by making a few changes there with this new feature. So there's plenty more great stuff in SQL 2014. We'll just scan through these, and you can read up on them as you like online or in your favorite book. Always on availability groups now supports 9 replicas. Always on, or AKA clustering. You can cluster with a local temp DB. Works on Windows 2012 Standard Edition. Cluster storage volumes, pretty interesting. And a lot of different new quorum options. In-memory OLTP, probably heard some about. Buffer pool extensions as well to add some auxiliary space to your buffer. And with that, we'll go to another poll question.
Thank you, Andy. We're ready for our final poll for today, and the question is, what newer SQL Server features are you most interested in if you upgrade? Always-on availability groups, in-memory OLTP, buffer pool extensions, writable column store indexes, or some of the lesser-known cool features presented today? Please take a moment to answer. Okay, and it looks like the results are in. So 21% of you chose always-on availability groups. 24% are most interested in in-memory OLTP. None of you picked buffer pool extensions. 36% chose writable column store indexes. That was the largest number. And 18% of you chose some of the lesser-known cool features presented today. Back to you, Andy.
Thank you, Stephen. For our last question today, we're going to look at how. How can we make this upgrade work? Well, here are a few ideas. First of all, let's talk about before the upgrade. Of course, super important to have a plan. Really, this whole presentation is about building that plan. So think it through, try to write it down step by step. Part of that plan will be taking a close look at your soon-to-be legacy server. Is everything up to date as much as possible? Compatibility modes, backups are there, maybe If you have a huge VLF count, try to reduce that. Basically, do some kind of health check here on your legacy server and bring the server as close as possible to where it's going to move up to anyway. Then also think about what's going to stop progress during the upgrade process. You can test any of these methods we're going to talk about. You can test them with a small backup. They just copy a very small backup of a test file from here to where the new server is going to be, or set up a log shipping with a very small test DB. Think it through and try to figure out what are going to be the key points or showstoppers that are going to be the gotchas when you actually try to do the migration, and play through those scenarios and make sure it's all fixed up before you go ahead with the upgrade. Okay, next you can look at the target server. Is everything up here up to the standards and following best practices? So assuming a side-by-side upgrade, you'll need to account for and move a copy of all the server level objects from the old server to the new server, things like logins and jobs, link servers, etc. Once you have all of these kind of tasks out of the way, you're ready for the upgrade. So when you are ready, there's a few techniques you can look at. First of all is simple backup and restore. It's about as simple as it gets. Back up the DB, move it over, and restore it. The big drawback is the downtime. Basically, the database will be offline during the time you are copying it from the old server to the new server. This slide doesn't show it, but the idea is once you take that last backup, that old DB will need to be offline. So there's your downtime as you're moving it over. Some of the pros here, it's super simple. And another neat thing is you can restore old compatibility. So you can drop back several versions. The backup of a 2005 database can be restored to a 2014 server. Another interesting technique, a favorite of mine, when I'm just moving, say, one or two databases, is log shipping. So here that final backup is a tail log of the backup, tail of the log backup, which is a log backup, but it also offlines the database all in one operation. So now no one can connect. Once you've done that, it's mostly a matter of rolling on the key logs on the new server. The drawback, again, is it has some downtime while you're rolling on those logs and reconfiguring the new server to accept connections. But the good thing here is that this whole thing can be set up well ahead of time, even like a couple of weeks ahead of time, and you'll minimize the offline time compared to a backup and restore. One of the cons here, as opposed to the backup and restore method, is the DB compatibility must be within 2 versions. Mirroring, this is a great one if your whole instance is moving. Work really well if you're doing some kind of DNS switch to repoint all the connections to the new server and you just want to take the old server completely out of the picture. It also has the least downtime. It's very similar to log shipping, and you can set it up well ahead of time. When it is time to cut over, there's a few ways to do it. One of them is simply take down the old server, just unplug it. This will leave the databases on the new server. In restoring data, you can go in, execute a final restore with recovery statement, and you're done. Some of the cons are very committing. Again, DB compatibility must be within 2 versions. Okay, after the upgrade, these are the kind of tasks that could definitely be on our checklist if we're running through after the DBs are up and online after the upgrade mission. We're going to want to make sure the database users are mapped to server logins. Redirect users, of course, have to repoint our connections to the new server. Check database consistency, update usage, update statistics, and we better check that database compatibility level. Of course, keep in mind the new Cardinality Estimator. All this stuff is pretty well documented. You can find it. Lots of good suggestions for this kind of thing online, and I think Datavale will have our own out there as well, so any kind of checklist you want to use. A couple more things to do after, of course, backups. We want to make sure those are done right away. And a health check. We want to make sure once those databases are back there and everything's up and running, make sure that whole server is up to healthy standards and best practices. Here's a quick rundown of some tools and documents, references you can look to for this upgrade project. Best Practice Analyzer, sort of Microsoft's version of Health Check. Database Upgrade Advisor touches on a few things we looked at here and some of the bigger gotchas that might grab you while you're doing an upgrade. Microsoft SQL Server 2014 Upgrade Technical Guide. Great document, very comprehensive, must be 400 pages, goes much more into SSIS, SSAS, SSRS, thinking about those kind of concerns, in addition to just upgrading the SQL engine. We offer our own Datavale SQL Server upgrade checklist as well as a health check and server assessments, and you can also look to us for some upcoming blog posts on SQL 2014 and 2016. So, in summary, here's pretty much what we talked about. What you want to do when you're making an upgrade project. Consider licensing, of course, and that might dictate your upgrade type. It may be in place, but in all likelihood it will be side by side. Provision the destination. You have to have a good sense of where you are now and how much resources are getting used on your legacy server. Think about where you're going to be in a few years and try to provision appropriately for that. Utilize the features. If you are on Enterprise Edition, you get all cool stuff. Everything's always online, always highly available, all these great options for data compression and partition, etc. Or at least this all could be. If you are running EE, it's really worthwhile to take a look at what's available and find a way to use it. On the other hand, Standard Edition, it's actually kind of a fun challenge as a DBA. Compared to Enterprise Edition, you're limited, but there's still some interesting options you can put in place there to see how much, kind of milk Standard Edition for as much as it's worth. So it's the same idea as for Enterprise. It pays off to be familiar with the options and familiar with your workload and try to find a good match as far as enabling and utilizing features. Lastly, plan the project. Probably goes without saying. It's really what the whole presentation is about. Look at what you have, decide where it should go, pick a method, write the whole thing out. This might be a requirement anyway according to your business requirements, but even if it's not, you'd be happy to have the whole thing written down. Last couple words. It just seems to me that people are sort of stuck on 2008 because it seems like a pretty big deal to move on and away and up from 2008. Should be simple. It was simple when it was 2005 to 2008, but it's not anymore. It's going to be more of a big deal. It's quite a big leap from 2008, 2012, or 2014, and it's only getting bigger as 2016 comes around. So these are kind of the things to think about, I think, looking at upgrading from 2008 is it's a good opportunity to take a look at the bigger picture and see where you want your SQL environment to look like a couple years down the road as we get more into the cloud and bigger and more feature-rich SQL Server versions. So that's it. Thanks a lot for attending the webinar.
Thank you, Andy. Before we move into questions from our viewers today, you will see a survey popping up on your screen. Please take a moment to select your answers. Also, just for watching this presentation, Datavale is giving everyone a chance to win a free upgrade assessment for your SQL Server. When you get an upgrade readiness assessment from Datavale, you'll have a team of experts evaluating your existing SQL Server deployment and identifying what issues you'll need to address before an upgrade begins. A random winner will be chosen, and you will be notified by email to take part. Datavale will establish connectivity and set up access credentials with your organization, then use a Datavale script to collect your database information at a time that's convenient for you. They will work with your DBA team and discuss the analysis based on the information collected during the assessment. While reviewing, their DBAs will provide recommendations and apprise you of the opportunities you may encounter when you upgrade. Now, let's move into some questions from our viewers today. Andy, first question, how would you figure out when to turn on the Cardinality Estimator?
Well, that would be a really good thing to test out ahead of time if you could. If you could have some way to capture whatever load is running against your legacy server, maybe a SQL replay trace, and then rerun that back on your new server, assuming a side-by-side kind of upgrade. Ideally, you'd be able to pull out which kind of queries would not be working well with the new Cardinality Estimator, and maybe decide to turn the Cardinality Estimator off. The new Cardinality Estimator, turn it off for those particular queries. That's how I would approach it.
Understood. Our next question, what about SQL Azure databases?
Oh, that's a good question. That's definitely an option if you had a resource sort of footprint that was a good match for a SQL Azure database. You definitely move that from your on-premise SQL Server into the cloud. And I think there's even a wizard in the Management Studio in SQL Server 2014 to do that, but that's as much as I can say. It's about as much as I've looked into that topic, so definitely out there.
Understood. Our next question, how about the detach/attach method for moving the databases?
Sure, that's an option. I didn't go into that one. I sort of prefer backup and restore of that kind of method, I guess, because you're going to back up the database anyway if you use the detach and attach. The detach is a little more committing maybe than just the backup and restore. And also the neat thing about the backup and restore method is that you can use a much older SQL version database, an older database compatibility level, whereas the detach and attach, you're going to be back to that 2 compatibility level limit.
Understood. That is all the time we have for questions today. We apologize that we were unable to get to all your questions, but as I stated earlier, all questions will be answered via email. I'd like to thank our speaker today, Andy McDermott, SQL Server DBA at DataVale. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived, and you will receive an email tomorrow once the archive is posted. As we stated earlier, just for participating in today's event, someone would win a $100 American Express gift card, and the winner today is Vince Carter. Vince, we will be in touch via email so you can claim your prize. Thank you, everyone, for joining us today, and we hope to see you again soon.